Okay, today is week 5. We are in chapter 4. Last week we discussed about superposition responses for different type of input. Okay, today we're going to look at the topic on convolutions. Okay, so as an introduction to convolution. Convolution is the general form of superposition response of linear system in time domain. So we are still in time domain. For LTI system described by its unit impulse response, the convolution of two continuous time functions xt and ht is defined by the integral as shown here. Okay, so in convolutions, we're going to find what is the output y. Previously, using superposition response, if we have input and output relationship for different type of input, we can use the impulse response ht at that time to predict what the output will be. So this is another way of getting the response, the output response, yt, using what we call it convolutions. So the formulation for convolution is yt equal x is our input, convolve with h, and h is our impulse response, unit impulse response. Remember last time we have, let me go back to our Jamboard. Okay, this one. Kalau kita pergi pada Jamboard last time, I think the last one would be on the 8. Okay. Okay. So this is our input, this is our output. So using this relationship, we can determine the yt, sorry, from whatever the input response is. In other words, usually we refer this as our ht. Okay. Now, after knowing the xt and ht, we want to use that information to determine the output of the system, but this time using convolution, what we call convolution. And the formulation is as below. Okay, so the convolutions, when we define as the convolutions, we can use the integral equations. Okay, so integral, and then one of the functions have to undergo the inverse, the reversals and the shift functions. So this is the formulations. So finally we have yt equal to integral of the input with the h, but using the but this ht or either one of them has been transformed into the reversal as well as shift. Nanti kita akan tengok explanation dia semua. When both xt and ht are right-sided, the limit of the integral are between 0 to 10, 0 to infinity. If, for example, that we have a functions more equal or more than 0, so the limit will be 0 to infinity. Okay. Okay, that is convolution in general. So what we're going to do afterwards is, we call it graphical convolutions. And this convolution will be, you'll be using it as well as for discrete time systems. Convolution is a mathematical tool to calculate the output of an LTI system when the input xt and the impulse response ht are available. So now that we have the input xt, we have the impulse ht, so we're going to use this information to determine what is yt. So when we rewrite this equation, we can conclude that a convolution is an integral that expresses the amount of overlap of one function when it is shifted over another function. Okay, the convolution integral may be evaluated by plotting the function x tau ht minus tau or xt minus tau h tau, meaning that yang melalui reversal shifted and all that, either x or h, vice versa. And then evaluating the area under the curve graphically. Okay, kalau kita lihat initially, the equation is yt. Kita nak mencari output time domain. And then the formulation is ht, convolve with xt, or either way lah. Tapi bila kita buat integral, the xt now has changed itu tau. Okay. And the h now is shifted and reverse. Okay. Sebab kalau kita simply tukar t kepada tau, x tau, h tau. Tetapi sekarang h bukan h tau, but then h minus tau. Dan kita pluskan dengan t. Ingat lagi, kalau plus shifted ke kiri ke kanan kelas? Hello?
Kiri.
Kiri, So kat sini apa yang dilalui oleh HT is actually the reverse minus tau, and then dia ada plus t. And then the integral is on d tau. So bila, maknanya in other words, t now change into tau, but with some shifting and reversal being done here. Okay, so that is for graphical convolution in terms of formulation. Okay, sekarang kita nak buat dia bagaimana, bagaimana, how are we going to determine or to do the graphical convolution in order to find what is our output. Okay, there are steps. Kalau kita lihat dalam beberapa textbooks ataupun reference, there are various, ada kata 5 step, ada kata 4 step, ada kata 3 step, but basically the step are all about the same. Okay, firstly, since we already have xt and ht, the input and the impulse response. So first, sketch graphs of the two signals and replace the variable t to tau from the two signals, and one signal will remain. Okay, sebab nanti kita akan buat shift. Jadi kita akan ada dua signal. We're going to have two signals. Okay, so I go back to my Jamboard here. So hari ni 12 graphical convolution. Okay, so given input xt and ht, so we want to find what is yt. Okay, let's say I have two signals lah. Okay, so my xt will be, saya ambil yang simple dahulu. And then we're going to look at the examples. So I have xt. Can you see class ada freeze lagi tak?
Tak ada, doktor.
Okay. Okay. So line fakulti ni last week memang ada problem. Menara Razak. Saya di Menara Razak. Okay, let's say saya ada dua signal. Kalau nak differentiate kan, mungkin I have one is the square and then another one is the triangle. So let's say I have one xt is impulse, and then I have ht is sawtooth lah. So let's say for easy demonstration, so this one maybe 2, and then this one pun maybe 2. Okay, so first step, sketch graph of the two signals and replace. First step ni kita kena tukar. So instead of t, I have to do tau. Okay, t I have to change to tau now. So saya buat color lain lah, hijau. Tau, tau. This one also tau. This one also tau. That is first step. And then second step, flip h tau around tau equal to 0 to obtain the reversal of that signals. Okay. So usually kenapa h? Kenapa tak x? So either one boleh. Usually dia punya tips dia, kita pilih yang mana lebih senang lah. Lepas ni that signals going to be shifted and then dia akan travel. Kejap lagi kita tengok. Okay, let's say dalam case ini maybe saya choose segitiga lah. So go to the next page. So I choose the h tau. So this is my h tau. H tau tadi segitiga kan? Okay. Tau. Initially I have seperti ini. So now I want to do the reversal. So macam mana rupa dia? Plus. Kalau reversal, so now it will be h minus tau. Padawan. And then tau. Sini tau. Kalau tadi tak mau keluar pula. Okay. Di sini. Two and two. If I reverse, it will be betul? Betul, number 2 tu betul tak?
Betul.
Okay. And then number 3, shift that by the amount t to obtain ht minus tau. So sekarang macam mana saya punya signal? Sekarang dia jadi ht minus tau. So how shall my signal looks like, class? Kita tahu dia punya apa tu?
Ke kanan.
Dia punya lebar dia. Okay, ke kanan. Lebar dia adalah 2. Okay, so saya shift dia mana-mana lah. So I shift dia dekat mana-mana pun. So let's say, tapi dalam keadaan the reversal already reversal. So let's say this is tau. This one will be macam mana?
-4.
-4. Dia tau. Dia bukan 4. Dia tau. So macam mana tu? Macam mana? Okay. So let's say this is anywhere. Kita namakan dia sebagai T. So this one will be T minus plus minus berapa? Minus 2 lah lebar dia, okay? Okay. And then multiply this two dengan yang asal tadi. Okay. So now we want to multiply. So how are we going to do that? So to multiply that is actually we are integrating these two signals over the range of that integrals. So this one is done using apa yang kita buat bila kita buat apa? Bila kita buat convolution, what we will do is, nanti saya akan tunjuk pada apa? Contoh So kita ada initially tadi kita ada satu yang so now dah jadi X tau lah. Okay. Dan saya tukar dia this one. Yang ni saya tukar ada merah. Apa yang kita buat next for this step, langkah yang keempat ni, kita akan gerakkan this H sebab yang ini yang melalui this part. Okay, so we will move this towards the XT and then we going to see how much dia akan overlap. Okay. Warna lain lah, hijau. Okay, so there are conditions when these two function will be overlap and this overlapping yang kita nak kirakan dia punya Y. Okay. So Y and this will be, dia akan ada beberapa condition. First, mula-mula tak ada overlap until this HT minus tau reach 0 and then afterwards dia akan start overlap with the square. Okay, until totally dia akan overlap and then afterwards bila dia meninggalkan after dia meninggalkan this segitiga, bila dia dah overlap slowly until at certain points there are no more overlapping as well. Okay, so this is what we're going to do today. We're going to look into how these two signals undergo the convolutions process. Okay, so basically these are again the steps. We have to, with given HT and XT, first step is replace the variable t with tau and then one of the signals kita we choose one of these two signals to be apa, to undergo the time reversal and time shifting. Okay, that's why yang chapter 1 tu penting lah, kita kena faham time reversal dengan time shifting and then after that we going to do the multiplication or the convolution between these two signal HT minus tau and X tau. And then the Y will be the integral of these two signals. Okay, so kat sini saya tulis, needless to say, the flip and shift may be performed on XT as well. Sama ada kita nak pilih sama dia XT ataupun HT, but only one of them lah. Satu akan remain static, satu lagi akan will be shifted and flip. Okay, konsep dia faham tak kelas? Sebelum saya pergi kepada examples yang very practical. So far okay?
Okay, doktor.
Okay, jadi tadi kita pergi pada contoh. Okay. To start with, I choose very simple two identical signal lah. So find the convolution of the unit pulse. Unit pulse ni yang ini. Dan kita tahu unit pulse is ut minus 1. Okay. So kalau ut sahaja, signal kita panjang kan. Tetapi kita tolak dengan ut minus 1. So this is how we get this pulse. So find the convolution of the unit pulse xt with itself. So maknanya di sini kita ada dua signals, one is xt and another one is ht, but both are identical. So first step apa dia kata? Sketch the signals and then replace t with tau, and then satu tu mestilah gone through the shifting and the flipping. So this is what we get lah. Sebab kita ada signal di sini. So one we have xt, and then another one we have, besar dia sama supaya saya tak nak you all confused. So bila kita dah when both of them will do the convolution, saya terus masukkan kepada kedua-dua lah dalam graf ni. xt h t minus tau. Kenapa belah? Why again class? Why it is on the left hand side?
Reversal.
Okay, reversal tu dia flip. Okay, so tadi
Shifted.
Shifted. Okay, so dia reversal sahaja minus 1 sebab kita tahu lebar dia satu. Tapi bila kita shifted, sebab kalau tengok shifted tu t tu adalah plus. Okay, so t, yang ni kenapa t minus 1? Because of the lebar dia ni lah. So t ni makna anywhere dekat left hand side. Okay, so anywhere in the left hand side. So that's why yang ni untuk h t minus 1 ke t minus 2, macam tadi example saya tu t minus 2 So this one kita namakan dia sebagai h t minus tau. This one is x tau. Salah tu tau tadi. So this one will be tau. Saya padam dulu. Okay. And then next we're going to do the multiplication and functions will overlap. Jadi dia akan banyak stage lah. Bila dia sampai, bila kita gerakkan dia, when we move this h to bit untuk berjumpa dengan this x tau signals, we have to move it to the right. Okay, there are some different cases lah. First will be before it meets the x tau, and then partially it will meet x tau until, because the two signals are identical, until both of them overlap fully, and then another case will be h tau will start leaving xt. Satu maknanya mula-mula dia approaching and then the leaving. Jadi kalau saya boleh bayangkan if I can imagine, dia dah start slow, takut lagging. There are different conditions. Kita sketch dulu So one will be, so I will do h tau ni different color lah. Maybe red. So this is x, and another one is red. Okay. So T masa ni adalah 0 lah. T minus 1. Okay, this one dia tak approach, going to approach. This is one condition. And then another condition, or another case, usually if you look at the reference, usually it names as case. Another case will be start overlapping and H tau is approaching. So saya kena buat yang ni. T minus tau. X tau. Okay, so let us look how it looks like. So saya besarkanlah supaya nampak satu ni kecil sangat. I make it bigger so that you can see.
Madam, I have a question.
Okay.
Why when we use the ut minus 1, we need to do the h function h?
The what?
I mean, the question is xt equals to ut minus 1, right? So the one that you do the ht is actually to do the minus ut minus 1, is it?
No, 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 no. Okay. The xt, this is the impulse. Impulse. Do you still remember how ut looks like?
It's like a square function.
Okay, this is ut, u, Okay,
Oh, okay.
u. And then how does the ut minus 1 looks like? This one. Right?
Oh, yes.
Okay. So when ut minus 1, so how will it looks like? The impulse. Xt. Yang ini tolak dengan yang ini. So inilah yang kita dapat. 1, 1. Only this one left.
Oh.
Okay. So this is just a definition for the unit impulse.
Okay.
Because ut is the unit step. Jangan confuse ut is the unit step. Ni dia panggil unit step. But this one is ut minus 1. Kalau ke depan kita panggil apa? Shift delay ke advance kelas? This one is
delay.
Delay. So ni dia ke sini. And then bila kita campurkan ataupun kita tolak ut minus 1, this is what we get, which is called unit. So dia tak ada kena-mena dengan H lain. So this is definition. The first part, this one is actually the definition for this unit pulse. How does it, macam mana dia dapat? This one lah. ut minus 1. So that is how we get this unit pulse. Okay, boleh? Did I answer your question?
Yes, understand.
Okay, so now bila dia kata ke sini, so we have two signals. Because convolution, if you still remember the step, convolution is two signals. One is the input, another one is the impulse response. So now that we have two signals, one is, but then these signals are identical. So one is actually, apa saya buat tadi? One is actually the unit pulse yang kita define tadi. Oops. This one. And HT is actually, ataupun kalau saya buat sini, so instead of HT yang ini, my HT now is also this unit pulse lah. So I have two identical signals. One. One is XT and another one is HT. And I want to determine what is the output, which based on the equation should be XT convolved with HT. So ini yang kita nak kira, convolution. This is convolution. But as we defined earlier, we can determine this using integral, the convolution formulation, which is given as this equation. Okay, where these two signals have to do some flipping and shifting procedures, one of the signals. So this is what we're going to do lah, yang saya nak tunjukkan. So these two signals, one remain, yang akan pergi kepada flip, this one H, this is H minus tau, and this is H T minus tau, yang jadinya sini lah. Okay, so now we have two signals. One is X tau, another one is H T minus, case ini 1. So tapi nama signal dia T minus tau lah. So now to do the convolutions, we need to move this Ht minus tau signals in to the right, so that there will be condition where these two signals will be overlapping, and we want to find what is the area of the overlapping of these two signals. Boleh ya? Sekarang kita nak tengok, we shift these signals to, saya tukar warna kot ataupun saya colorkan dia lah. So this one red. It will move to the right, and then we want to find the area. Okay, so before finding the solution, before finding the area of these two curve when it's undergo the convolution process, kita kena tengok dia punya condition ataupun cases. If you look at the reference, it's refer as cases. So there will be a cases where there is no overlapping. Bila macam ni dia tak ada overlapping kan. Jadi bila tak ada overlapping, these two signal kalau kosong, saya kata yang ni, bila keadaan dekat sini dia tak ada overlapping, so kosong lah. And then there will be time dia nak mula start overlapping. So let us look how it looks like. Okay, let's say this is my another signal, dia dah start overlapping. T, then T minus 1. Ini case, first case before overlapping, and then yang ni dia start overlapping. Okay. Yang merah is Ht minus tau. And then there is also a case, since both are the same units and the same amplitude and so forth, there will be cases where both will be overlapping at the same time. Jadi pada masa yang sama dia akan overlap juga. So this is case 3, sorry. Terus lagi. And then next will be the red one is going to start to leave. Okay. Start to leave this black one. So ini dia punya overlapping. So this one tadi kita kata dia T minus 1 T minus 1 dan sini T. And then this is case number, tadi kita dah apa? Case 3. So this is case 4. And then finally, where there is no more overlapping. La ilaha illallah. Sengit. Ayah. Nak kata tak makan, nak makan lah ni. Oops. Ya, sengit juga. this is the X tau, and then this is the H tau. Dia dah tak ada start living So this is T minus 1 and 0. So this is case number. Okay, again, when we move this H T minus tau signals to the right, there will be 5 different cases. First one, when there is no overlapping. Okay, sepanjang-panjang ni bila dia gerak, dia tak overlap. So there is no overlapping for the red one and the black one. And then number 2, where this red one is approaching the black one and there is start to overlap. So the red and the black start to overlap. And then case number 3, when they're fully overlapping each other, kita tunjukkan that the motion is to the right. The right. And then this one, the red one start to leave the black one, and finally there is no overlapping between these two signals. So ada 5 cases. So far yang cases saya mention ni faham tak? Sebelum kita pergi detail kepada the calculation of the area. Okay so far?
Okay, Doktor.
So case 1, case 1 dia, kalau kita tengok dia nak start overlapping when T more than 0. Okay? Bila T itu dah positive value, then we can see there is overlapping. So before this, there is no overlapping. So that is where T less than 0. So this is the first case. So if you look at the notes here, so when T less than 0, two functions do not overlap. Therefore, area under the product of the function is 0. So since there is no overlapping, so kalau kita tengok definition, Y adalah X and H. So since there is no overlapping, the value is 0. Okay, dia tak overlap. And then the second case is that we start to see overlapping, especially between the value of 0 to 1. Sebab kita tahu sini dia punya the width of that signal is 1. So dia akan start overlapping sikit sehingga T equal to 1. Okay, so this is shown here in the notes. Okay, so now since there is overlapping, so we have to find the area under the curve lah, because integral adalah area under the curve. So area under the product of this function is the limit. Bila buat convolution, dia punya trick dia adalah pada limit dia tu. So kalau kita lihat di sini, dia start at T sehingga 0. Okay, sebab T ni akan bergerak sehingga dia habis ni T equal to 0 lah. So the limit will be 0 to T, and then bila since the amplitude of this signal, both signals are 1, 1 times 1 is 1 d tau, and then bila 1 integrate d tau will be tau, and then the limit is 0 to T. So our yt from 0 to 1 is T. Okay, so di sana nak buat ni tadi. Okay, background. Okay, so first T case 1 case 1, T less than 0, we see that there is no overlapping, therefore our yt equal to 0. And then case 2, when T is between 0 to 1, we can see that there is a overlapping here, and when we calculate the YT is equal to T. Okay, sampai sini ada pertanyaan tak? For example, kenapa limit dia 0 to T ke apa ke? Okay.
Okay, Doktor.
Okay, so kalau nak tahu limit tu kita tengok kat sini lah. Because the overlapping here is between T to 0. Kalau kat sini dia tak overlap, so kita tak boleh kira ni. Kita kira bila dia overlap. Bila dia tak overlap, maknanya dia signal ni time dengan 0, dia akan dapat 0 kan. So this is dia punya limit lah between T to 0. So this is for case 2 kan. Okay, so if you understand for case 2, now we look at case 3. When T equal to 1. Okay, pergi balik semula kat signal sini tadi. Okay, so sekarang kita punya yang merah tu adalah T minus 1 dengan T kan. Okay, ni T minus 1. So when T equal to 1, so this one will be 1, this one will be 0. So kita dapati di sini bila dia overlap, when it is overlap, the value is, area dia 1 lah, okay. 0 to 1, 1 T, kita akan dapat 1 case 3, sorry. So case 3, T equal to 1. Ni tadi T. T kan? Yes, T. T equal to 1, so our YT will be 1. Okay, dan keempat. Number 4, case number 4. Refer back to the diagram. Ni. Okay, case number 4, the red one is start to leave the black one. So if you look at the limit will be, yang dia overlap is this one lah. Between T minus 1 dengan 1. This value is 1. Okay, so we integrate T minus 1 to 1. Okay, again, since these two signals are 1, 1 times 1, 1 d tau, and then again tau, and then kita substitute the value, the y will be, this one tadi saya kata apa, t between, okay, t between 1 and 2. Okay, so our y t is, so tolakkan 1 minus t minus 1, so we have 2 minus t. Okay, and then finally case number 5, look back again, ada dah leave, so no more overlapping here. Okay, so that is when t more than 1. Okay. More than 1. Okay. Sekejap. So this one kita tahu value dia is this apa? The red one, the width is also 1. So if this is 1, this is 2. Okay. So bila t more than 2, so no more overlapping. So our signal will be 0. Ini tadi So now t equal to 2. So tak ada overlap lah. Okay. Okay, now these are the conditions that we have. Less than 0. kosong. Tapi between 0 to 1, the y is t. So 0 to 1, the t. Until t equal to 1, 1. And then ni saya buat besar-besar kat sini, nampak kot Allah. Okay, so this is 0. So my signal will be red lah. So 0, the 0. Until 0 to 1, it will be 1, 2, 1, until is yt. Okay. Okay, so from 0 to 1 is t, so this is t lah. And then 2 minus t here. And then after that 0. So this is our output yt after the convolutions. Boleh kelas? Okay, so far?
Okay.
Okay, Doktor.
Tak ada soalan Semua faham Okay. Mana tadi? Okay, so to make sure that you understand fully this concept, let us look to some exercises. Jangan tengok solution dulu. Okay, cuba kita buat bersama. Okay, for exercise 1, we have again two rectangular pulses, but then this time the width and the height is a little bit different lah. So untuk A dan B, dia punya amplitude sama, 1. But for the first signals, the T is 2 seconds, and the second signal, the T is 4 seconds. Okay, so function xt and ht are both rectangular pulses as shown in the figure. Apply the graphical convolution to determine yt equal to xt convolve ht. Okay, can we start now? Saya bagi 5 minit, 10 minit cuba dulu kelas. So we look one by one. First kita tukar pada tau, and then one of the signals, let's say you choose A or B, has to undergo this flip and shift. Okay, so be careful with the T and T minus ni. Maknanya signal ni kita bawa anywhere dekat belah kiri, so kita namakan dia T lah. So bila T, yang hujung dia tu mesti T minus how much lebar dia tu. Okay, ke 2 ke 3 ke, kalau sikit. Macam for example like previously yang sini, sebab lebar dia 2. So bila dia shift ke sini, this one T, this one will be T minus 2. We already learn kan, kalau yang belah sana tu dia adalah belah kiri. Kita belajar shift and reversal previously. Okay, so first step, please do this one. Buat pada graphical so that you understand. You have x tau and ht minus tau. So either lah, kalau nak buat yang ni, yang shift pun boleh, yang ini pun boleh, mana-mana tadi kita cakap. And then try look at the cases. Cases where initially no overlapping, and then they start to overlap, and then maybe they are the fully overlapping, and then one start to leave, and then finally no overlapping. Buat satu-satu Tapi but now different case because the amplitude and the width the T tu different. Jadi saya nak you all bayangkan and then the trick part will be, if you look while we do the, bila kita tengok cases ni when I say that convolution can be divided into 5 parts lah. Allah, saya dah pergi advance pula dah. Okay. 5 parts where initially no overlapping and then start to overlap. Jadi the trick dia sebenarnya adalah at the equations. One will be on the limit, finding the limit yang ada overlap, and then another one will be the equations lah. But then initially I start giving you examples only on the rectangular, senang. So value dia tu tak ada t square ke kalau macam exponential, so you ada e minus 2t, ataupun kalau triangle macam tadi tu, triangle ni payahlah sikit ni. So this one will be t lah kan. Bila dekat sini dia dah minus t dan sebagainya. Tapi yang ni saya start bagi constant dulu So we look at the constant value, sama ada 1 ke ataupun dalam exercise tadi 4, 2 sebagainya. So kita tengok different, and then this one will be the trick part, finding the limits, and then yang lain-lain saya rasa if you follow through, so you can get that. Okay, so look at the cases first, finding the limits, and then try to look at the product ataupun the area under the curve. Okay, 10 minit, try.
Tutor, just now is exercise 1, right?
Sekejap yang ni. This one. Buat yang part A dulu
Okay.
Once you get the part A, part B, part C will be the same. Part A ni dia sama tinggi, part B and part C dia tak sama tinggi lah. You all buat dulu, saya start pilih.
Tutor,
Yeah.
the B, is it going to be a weird shape?
The what?
The B one.
Mm-hmm.
Is it going to be a weird shape because HT is smaller than XT, right?
Mm-hmm.
Oh, okay.
Shape is about the same, it's just that the amplitude maybe will be different. Boleh?
Doctor,
Ya.
the convolution, is it like the area that overlapping or the area, is it the area of overlapping?
Yes, yes.
Oh.
Dapat?
Dapat, doktor.
Dapat semua tiga-tiga.
For the A one, right?
Okay, I'll let you share your. Sekejap Proceed with B and C as well, Dia tak masuk. Saya letak dekat e-learning. Can you put your answer here? Apa ada dua ni? Saya akan delete satu. Okay, class, can you put your answer here? Jadi saya boleh semak betul tak betul. Anyone to share your answer? You all nampak kan e-learning ni? Sekarang?
Can see.
Nampak.
Okay, so siapa yang nak share mungkin kita discuss betul tak betul? Discuss on the answer before going to another example. Suara masukkan. I'm waiting. Tak ada siapa nak share ke? Anyone would like to share your answer?
Is uploading.
Uploading. Oh, lambat anyone? So far tak ada lagi ni. Macam mana kita nak discuss? Tak ada ke? Okay, saya dah nampak satu.
Saya dah send doktor.
Okay, saya tengok jap. Mana Oops. Okay. Seorang je. Ni. Yang ni ke?
Saya rasa saya dah upload. Sekejap, saya check.
Yang ni siapa punya? This one?
Ni bukan saya saja.
Mi tu siapa? Sebab saya tak nampak.
Atika.
Ha?
Atika.
Atika. So where is your Y?
Huh? Why? Tu?
Mana Y-nya?
In the graph?
Where?
In that graph, YT.
Oh, kita kena combine kan
That's the combined one.
Which one?
A, B, C. All got.
Okay. Let us go back to this one bila kita combine ni, kita dapat ni. For these cases, from 0 to 2 ni, 0, before 0 kan saya tunjuk tadi. I did show you at the ni yang saya maksud bila kita dah combinekan when this condition satisfied, all these 5 cases, and then kita combinekan dia lah. This is when t less than 0, this is when t between 0 to 1, and then t equal to 1, t between 1 to 2, and t more than 2. This is what I mean, the whole YT responses. Kalau tengok mana ni you buat sikit-sikit kena combine.
Oh, combine A, B and C.
Semua lah bila kita dapat ni, kita kena macam sehingga macam ni, tak boleh stop sehingga 5 You cannot stop until number 5. You have to conclude everything. So this is finally your YT, and then represent that into the graph. This
So
is
I need to make equation or for each A, B and C.
Yes, something like this.
Oh, not combine the YT, all the YT.
Also YT. This kena ada dua. Kena ada dua. One is this one, and then another one is the whole thing. Okay? Kita tengok tadi tu yang kita buat satu-satu just now. Where is my Jamboard? Yang ni tu kita tengok satu-satu we look at cases lah. Case sebelum dia overlap, and then the start overlap, and then the fully overlap, and then dia start partial overlap and no more overlapping. So dia ada 5 condition kan bila dia gerak tu. Sebab bila dia overlap, kita nak kira area under the curve tu, that's why kita buat integrations and then fully overlap, and then this is the condition. And then bila kita dah dapat condition tu, kita tuliskan lah. So before ni dia tak overlap, so no more overlapping, so the product is 0. But then between 0 to 1 dia start to overlap, and then itu yang kita buatkan equation di sini. Number 2. Okay. So this is how we get T ni. Macam gini. Ini dia. Okay. Because YT is between 0 to T. Itu yang saya cakap limit is very important. Kita tengok kat sini overlap dia is between 0 to T. And then dua graph akan overlap, which is because in this case dia punya amplitude adalah 1 and 1. So 1 times 1 d tau, and then kita tukarkan, kita buat integration, so kita dapat T. So between 0 to 1 YT is T. T apa dia? Persamaan garis lurus lah. Okay, Y equal to mx kan. So bila kita represent dia dalam graph, this is T. This one is T. This one apa tadi kita dapat? 2 2 minus T. 2 minus T masa case 4. 2 minus T. 2. This one case 2. And then this is masa dia fully overlap. And then ni apabila more than 2. So that is why we dapat yang ni. Ini yang kita nak. And the answer should have this one as well as the graph. Boleh Atika tadi?
Okay.
Okay, boleh So kena baiki balik. So siapa lagi yang dah masuk? Okay, Dini. Okay, Dini masuk. Okay. So kalau kita tengok Dini, 2 orang je, Atika dengan Dini je masuk. Aduh, you all ni. Okay, so this one the start overlap. Okay. So less than 0. So between 0 to T. Okay. So then dia fully overlap. Sebab 1, 4, 1, 2 tu kena tunjuk macam mana gambar dia dapat tu. Dini and then they start living and then okay. Okay. Yang lain macam mana? Faham tak? Because I cannot see others. So Atika kena baiki, okay, di ni in terms of ni je lah, nak kena cantikkan sikit Yang lain sebab tak bagi saya tak share, jadi kita tak boleh discuss lah. Hello, 2 orang ni je ke dalam kelas ni? Hello? Bilangan ada 20 ni.
Ada doktor, I tengah buat lagi.
Tengah buat lagi. Okay, so kita ada lagi few minutes. Okay, buat dulu. Tapi kalau, so while you're doing it, kalau tak faham, kena tanya
Right, doktor.
Okay, yang lain? Adam? Apa lagi kat sini? Farizwan, Luqman. Apa lagi? Farouk. Okey tak? Selagi tak mahir convolution ni tak boleh lah nak masuk Laplace. Okay, I have more yang dah masuk. Tak juga 2 orang je. Ya Allah, betul lah korang. Dua orang je baru masuk. Yang lain mana ni? So, kita tengok tadi case 2 partial dia baru start di sini. And then case 3 okay. Dengan case 4.
Doktor, I don't understand case 2.
Case 2 tak understand macam mana. Okay, this is yang X X dia kata sorry, not X, A. A dia punya ni ada 1 and T1 is 2. So this one kan 2. And then B tu 1 juga tapi T dia adalah 4. So lebar dia ni 4 ni yang merah ni So it will start overlap bila merah ni datang sini. The start overlap between T, okay, until kalau kita lihat dekat sini bila case tu dia sampai kat sini.
Doktor, why it needs to be shifted?
Convolution. Itu yang awal tadi. Convolution. Sebab kita buat convolution. Graphical convolution is a mathematical tool to calculate the output of an LTI system when the input XT and the pulse are available based on this equation. Okay, the equation is a convolution, XT convolved with XT. Tetapi bila kita demonstratekan dia in terms of integral, so this is where the T is changed into tau and then one of the signal has to go the flipping and the shifting. Okay, kenapa kita shift? Okay, kenapa kita shift? Sebab kita nak gerak-gerakkan dia, nak buat convolutions. To see, to look, to find the area under the curve. Okay, boleh? Okay, saya lebarkan sikit lah yang ni okay, dia akan shift sini. Tapi dia tak apa? Sehingga
Doctor, after put the integration, then how do we integrate them?
How do we integrate them? Okay.
Yeah, because it's X and H, right?
X and H, but this H is actually HT minus tau. Okay, so that is why we have to look into cases or into parts. So then we understand how it looks like. Okay, for example, like this one, between T to 0 to 1, ni example yang mula-mula tadi from 0 to T0 to 1 kat sini, dia akan ada overlapping here. Okay, so this overlapping is the integration between these two signals, which in this case both are 1. Okay, so 1 kali 1, 1 lah. And then kita apply the equation of the integral. Xt times ht minus tau.
1 is what is the
value,
y length?
The amplitude.
The amplitude.
Yeah. Later on kita akan tengok amplitude yang berbeza untuk exercise. So first fahamkan yang ini dululah. Boleh?
I don't understand.
Tak faham juga.
I don't understand anything.
Tak understand yang mana?
I just don't understand where to put the XT and HT when it's case 2 and 3 and 4 and 5.
Which one? Because of the convolution. That is why I explained earlier the concept of convolution. Okay. Boleh tak? Tak boleh juga. Let me look at the... tak tambah. Okay, lim dah tambah. Lim satu page je Lim.
Saya ada hantar first page.
First page tak masuk Okay, tak apa, dia slow sikit.
Dekat bawah.
Oh, okay, here. Ni second. Sama je dua-dua.
Jangan, sorry.
Okay. Yang lain ni macam mana ni? Saya tak tahu you all faham ke tak ni. Saya takut macam Atika tak faham kenapa Atika. Right? This is a convolution concept, Atika.
Yes. I don't understand where to put the square for each case.
How to put the graph?
Yeah.
You have to do a lot of exercises to understand that. So kita saya baru tunjuk yang simple one dulu. This is the simple one. Kita tengok case by case. Mula-mula dia tak ada overlap, and then dia start overlap, and then dia dah masuk sini. Then lepas tu dia start leaving, and then tak ada overlap. So the same goes to yang kita punya lah, yang the next one. And then bila kita understand the cases, and then we put that equations.
So it means like like the movement for each case is like it depends on the what on the overlapping area.
Okay, I think the best one, you all nampak semua screen saya tak? Dia ada satu, if you go to the, okay, saya Google sekejap I think that one will be a very good Wikipedia pasal convolution. Graphical. Sebab saya punya komputer ni, Keynote ni dia tak boleh Wikipedia. Convolution. The GIF yang ni bagus to demonstrate. Let me look at it. I think this one. Okay, nampak tak ini?
Yes.
This is actually what happened.
So which means HT like it moves bit by bit.
Yes. Jadi bila dia move tu, kita kena cari dia punya summation. Yes. That's why yang hitam tu adalah produk dia. This is a very good demonstration. Okay, so initially dia tak overlap, dia zero. And then dia overlap. Kita nak cari dia punya produk. Okay. But then as I mentioned earlier, the trick is, bukan the trick lah, maknanya kita kena careful dia punya condition sebab every condition yang dia pergi, macam for example like between 0 to 1, kalau kita tengok dekat sini 0 to 1, partial dia sahaja yang overlap. Okay, so that's why dia naik situ. Sehingga dia fully overlap masa dia betul-betul at 1 tu. And then dia start, bila dia turun, kenapa dia turun? Because dia partial sahaja yang overlap. Okay, jadi serupa juga dengan yang ini. Saya terus sebab kita ada few minutes lagi ni. More examples will be right Thursday lah. Okay, saya terus pergi pada the notes So the first one, please siapa yang masih tak faham lagi, nanti try masuk kepada Padlet dalam e-learning. So the first one sama juga dengan contoh yang saya bagi previously, but then only the dia punya width tu sahaja berbeza lah. This one, in this case, T1 is 2, T2 is 4. Okay, let's say I choose the T4 is the one that's going to move. So there are also the same case, 5 cases. So initially when no functions are overlapping each other, so the product again is 0. So this is when T less than 0 lah. Sebab bila kita gerakkan HT minus tau ni, dia tak akan overlap selagi T tu belum melepasi, T yang depan ni T belum melepasi 0. So as long as T less than 0, there is no overlap. So the YT will be 0. And then dia gerak lagi, dia gerak sehingga dia start overlap selepas 0. Okay. So if you just imagine the HT minus tau moving here and then start to overlap whenever T more than 0. Sebab this pulse is 2, kita nak tengok dia overlap from 0 to 2. Sebab bila 0 to 2, ada yang ni yang tak overlap. Yang balance, sebab dia kalau if you still remember this one, dia punya lebar dia adalah 4. So bila dia start overlap ni sehingga yang betul-betul dia overlap 0 to 2 lah. And then dia ada balance lagi. So between 0 to 2, kalau if you look at the blue one, the overlapping area is actually between T to 0. And then the function is both 1. And then bila kita buat integrations, so we have again another T. Okay, and then next let us look at the case number 3. So between 2 to 4. Okay, so sekarang kita punya T2, kita bayangkan kat sini 2. And then this is our T. Okay, so T ni 2 to 4. Okay, the two function sama juga, tetapi sekarang dia punya T ni lebar dia ni bukan apa? Dia punya overlapping here kat sini. So the limit is between 0 to 2. And then bila kita, sebab masa ni dia fully overlap to each other lah, between 0 to 2 kan, sebab saya buat di sini ya. Close this one. Mana saya punya Jamboard tadi. Kita cuba bayangkan
Doctor, the square on the right side is until 2s
ini yang kes ketiga lah. Kes number 3 kan. Sebab satu tu dia 2 sahaja. Dia punya apa, tak balance tak apalah kan, dia jadi square. Okay. Dan satu lagi tu merah, sorry. Satu lagi tu yang merah tu dia punya lebar tu sampai 4 kan. Jadi kita bayangkan dia sinilah. Ini bila dia overlap tu kat sini. Ini case number 3.
Doctor, just now the condition, the third condition is T equals to 1, right?
The third condition,
Yeah.
both equal to 1 sebab dua-dua ni dia punya tinggi dia 1.
No, I mean the time.
Number 3, time.
No, the one that we do just now. The doctor said the condition for third is T equals to 1, right?
Ya ni.
Yang A, B, C.
Contoh yang ini ke contoh exercise ke contoh example?
Yang kita orang buat tadi.
Yang ni lah 1A ke?
I guess so.
This one lah. Okay, this one.
But right now Y is 2 and 4.
2 and 4.
Yeah.
Kalau tadi kita buat 0 to 2. Okay, you all bayangkan. Ni. T ni bergerak. Okay. Dia bergerak ke 0 to
2. Okay.
Okay, lepas tu dia bergerak ke sana. Okay. Lepas tu sebab kalau kita ingat dia punya apa tu?
It will move like 1 unit every time it move.
Bukan 1 unit. Kenapa kena cakap 1 unit?
1 unit on the x-axis. Is it?
1 unit on the x-axis. Tak, bila dia gerak sehingga dia akan bertemu di sini lah. Oops. Dia gerak sini, saya lukiskan perlahan-lahan and then dia bergerak lagi sampai ke 4 sebab dia besar. The red one is, kalau kita tengok the red one is 4. The black one, saya color. Okay, the red one 4. The black one 2. The black one yang tak pergi mana-mana tu, yang tak gerak tu, 2. Okay, so you bayangkan yang merah ni dia bergerak dia sebab dia from here. Yang merah ni tadi dia from here. Okay, so bila dia bergerak, dia akan masa tu dia 2, dia sehingga nanti dia pergi ke 4. Dia bergerak sini terus sehingga nanti dia akan, katakan kita bayangkan dia 3, bila dia 3 kat sini, So 2, ada sikit lah sini. So sini dia masih lagi overlap. So this is, sekejap, kasih saya habiskan sekejap. So this 2, this T and this is 4. Boleh bayangkan tak, sehingga dia pergi ke 4, okay, where 4 tu nanti ekor dia je yang tinggal. Sampai dia 4, dia akan fully. Ni sebab dia tak habis ni, sebab dia tak sampai 4. Bila dia 4, bila this T tu dia sampai kepada 4, jadi 2 3, 4. Sebab yang merah tu kan sampai 4. Salah kali. Yang merah tu kan sampai 4. Okay. Dia sentiasa from 2 to 4, bila merah tu bergerak between 2 to 4, dia sentiasa akan ada both of them are fully, apa orang kata, fully overlap. That's why unit dia dapat 2 sini. Faham tak? Kalau sebelum ni tadi, 0 to T dia tak fully overlap. Sebab ada yang akan kosong, ada yang overlap kan. Tetapi kat sini dia fully overlap when T is between 2 to 4. Sama ada dia macam gini, ataupun dia macam gini, ataupun dia macam gini. Ada banyak condition. Ini dia katakan T dekat 3, dia masih lagi fully overlap. Bila T kat 4, dia masih lagi overlap. Fully. Do you understand what I'm trying to say? Plus?
Yeah, but for each case, is the
This
time
is,
condition?
This is case number 3. Still case
Yeah.
number 3. Tapi saya,
I mean for this case number 3 just now is
between 2 to 4.
between 2 and 4, right?
Mm-hmm.
But the one that you teach before is T equals to 1. The first one that you give the condition.
T equal to 1. Ni ke?
No, the first one, the at 2 p.m. just now. The simple one.
Contoh ni.
I guess so. 1, 2, 3, 4.
One yang
Yeah, that one. Yeah.
Oh,
How to know what's the T equals to what, blah blah blah.
One, okay. Because this one, dia dua-dua sama size tau. Dia fully kalau kita kata two functions fully overlap because the same size. The same size masa T equal to 1.
So how do we know what to write for each case?
That's why you have to do some graphical imagination lah, macam dalam case ini, sebab dia tak sama besar. Okay, 1, 2, 1, 4.
So
Jadi
does it mean
dia memang fully overlap, tapi dia ada keadaan dia.
does it mean like each case tu have different answer?
Yes.
It's possible lah. Oh, I thought there is like only one answer for each.
Tak. Tu sebabnya saya buat banyak contoh. That's why I give you more examples, step by step. Mula kita buat two X and H the same size, and then kita tengok X dengan H a little bit different size, and then kejap lagi kita tengok height dia tinggi sikit. Jadi kita nampak what the condition macam yang ini. Bila 2 to 4 ni, sebab yang merah ni dia lebih besar, dia bila masa T sama dengan 2, dia overlap fully. Okay, tetapi dia ada satu yang tak overlap ni. And then bila katakan di T equal to 3, dia ada overlap, ada sini tak overlap, sini tak overlap. Until dia sampai ke 4, T equal to 4 ni, ujung dia tu memang fully overlap. So meaning that, bila kita buat condition number 3, they always overlap with the answer area under the curve 2. Satu kita dapat melalui this equation. Satu lagi kita tengok graphical. Memang area overlap dia adalah 2 lah. These two. 2 kali 2 ni. 2 dengan 1 ni.
Okay.
Okay. And then bila case number 4, dia dah start living. Dia dah start living. Okay, kita dah terlebih masa ni. Case number 4 dia start living. Saya tunjuk last lah this one, nanti kita discuss lagi. Start living, number 2, and then yang start living lah. Dia tinggal hujung dia je. Hujung dia sahaja yang beroverlap. That's why limit dia is, yang ni kita tahu kalau merah tadi T hingga T minus 4 kan. So kita nak tahu limit. This one convolution yang very confusing adalah nak tahu limit. Kalau kita tengok keadaan number 4 ni, macam mana kita tahu limit dia between T minus 4 to 2? Ni kita tengok yang dia overlap ni. 2 hingga T minus 4 to 2. And then we put that. Kita dah tahu dia punya limit, kita masuk dalam equation, so we dapat 6 minus 2, and then finally selepas 6 dia dah tak ada overlap, and then finally we have this equation and then plot that graphically. Okay, boleh?
Okay.
Kenapa lepas 6? Sebab kita tahu yang hitam ni dia punya lebar dia 2 kan. Yang merah lebar dia 4. So bila ini dia dah tak overlap lah. 2 dan 4 campur dengan ni 4. So this one will be 6. So more than 6 dia tak overlap dah. So the YT will be 0. Okay, so please class try to do exercise B dengan C ni. Make sure that you understand. Okay, and then kita akan discuss more on Thursday, boleh?
Okay.
Boleh Doktor?
Any questions so far?
So far no.
Okay,